Everyone, welcome back to our channel. Today we are going to discuss about laws of motion, very short answer questions. From what is the weightage of this chapter is 6 marks. 2 marks are from very short answer questions and 4 marks from this chapter. Total 6 marks are there, and it is very important chapter for final exams also. In this chapter, heart of this one is Newton's laws. You know that there are 3 Newton's laws. Newton's first law and Newton's second law, Newton's third law. Based on this, many applications and whatever the fruits are there we are enjoying now, these are the Newton's 3 laws. So we are going through one by one very short answer questions. Our first v.s.a.q is what is inertia and what it gives. The inability to change its state of rest or uniform motion, that is called the inertia. Suppose this board is there. This board is continue its state of rest because of its inertia, and earth is revolving around the sun, uniform motion it is having. It is continue its uniform motion because of the inertia. So here we can treat rest and uniform motion, both are same only. Unless we are applying the external force, the body will continue its state of rest or uniform motion, that is called Newton's first law. From that we are getting that inertia, inability or resistance to its change of state. State means either rest or uniform motion, that is called inertia. What it gives, mass is the measurement of inertia. Then our second very short answer question is what is Newton's third law? From that this question is coming, why action and reaction never accompanied on the single body? Means action and reaction, generally what we are taking, this is one body, this is one body. Suppose this force is acting on this, another force is acting like this. Here resultant force is how much? 0. On single body, if two forces are acting in opposite direction, our angle is 180 degrees, both are cancelled together, we are getting, in this case, resultant force is equals to 0. But the question is, in Newton's third law, from Newton's third law, for every action there is always an equal and opposite reaction is there. Rocket is going upward direction, but the fuel is coming downward. Action is on rocket, reaction is on fuel. So here resultant force is not equals to 0. Why? Action and reaction both are not acting on the same body. We can say here F12 equals to minus F21, but resultant force is not equals to 0. Why? Action and reaction never acting on the same body. The example is rocket is on the rocket, action is there, reaction is on the fuel. Even we are using the gun and bullet problems also. These are the examples for this. Then third very short answer question is, when a bullet is fired from the gun, why the gun is giving kick in backward direction? You feel this is the gun, this is the gun, this bullet is there. See, initially what happens, gun and bullet both are at rest condition only. So before firing, momentum, initial momentum equals to 0. Then after firing, we can take it that momentum is mass of the gun, velocity of the gun plus mass of the bullet into velocity of the bullet. For this type of questions, first we can say that from the law of conservation of linear momentum, means if there is no external force acting on the body, momentum is constant. Before firing and after firing, momentum is constant. So before firing, momentum is 0. 0 equals to mg/vg plus mb/vb. Momentum of the gun plus momentum of the bullet. When we are taking mb/vb, it is going forward, means we are getting here momentum of the gun is negative. So when the bullet is going forward direction, gun is giving kick in backward direction from the law of conservation of linear momentum. Then our fourth very short answer question is, why does a heavy rifle not recoil as strongly as light rifle? Heavy rifle means that mass is more. Here also we can say that from law of conservation of momentum, if there is no external force acting on the body, look here, F equals to rate of change of momentum. If external force equals to 0 means momentum does not change with respect to time. P equals to constant. Instead of P we are writing mass into velocity is constant. So mass is inversely proportional to velocity. If the mass is less, velocity is more. If velocity is more, mass is less. If the mass is more, velocity is less. That's why heavy rifle is having the less velocity comparing with lighter one. Our fifth question is, if the bomb is exploding into two pieces, why the pieces are moving in opposite direction? Here also in that answer we should mention from the law of conservation of linear momentum. If there is no external force on that, then what happens before explosion and after explosion, momentum is constant. Anyway, before the explosion the bomb is at rest means momentum is equals to 0. Then after explosion, what is the momentum? See, before explosion momentum equals to after explosion. This is the first part momentum plus second part momentum. When we are doing the simplification, m1 v1 equals to minus m2 v2 means both are moving opposite direction. Our sixth very short answer question is, define force. Reverse of that inertia, the ability to change its state of rest or uniform motion. Even the body is at moving condition, uniform motion, or the body is at rest. This physical quantity is try to change its state of rest or uniform motion, that is called the force. Then there are four basic forces in nature: gravitational force, electromagnetic force, strong weak nuclear force, and weak nuclear force. Then our seventh very short answer question is, can the coefficient of friction be greater than 1? Generally what we are saying, yes, it's not possible like that. No, it is possible. First we can say that whenever they will mention in this question can means you can say yes, coefficient of friction be greater than 1 in some situations. In that, what is the first one? When the surface is heavily polished, then coefficient of friction be greater than 1. See, generally because of the elevations and depressions, two bodies are interlocked together. This is A, and this is the B. When two blocks are placed together, both are interlocked together and friction is acting. Whenever we are polishing that moderately, friction is reducing. If you are doing more polish, what happens? Because of the adhesive forces, friction is increasing. So coefficient of friction be greater than 1 in this case. Then our eighth question is, why flattened tire is coming rest faster than the inflattened tire? Flattened tire deformation is more, so rolling friction is more. That's why it is coming to rest easily comparing to the inflattened tire. Then our ninth v.s.a.q is, one horse cart is there. Initially we should apply more force on that. You know that there are three types of frictions: static friction, sliding friction, rolling friction. Which friction is more? Always static friction or limiting friction. Means maximum of static friction is called the limiting friction, is greater than kinetic friction. Then it is greater than rolling friction. So initially the horse cart is at rest condition, means for overcoming that limiting friction we have to apply the more force. Then our 10th v.s.a.q is, this is also belongs to coefficient of friction. If we are increasing the weight of the body or we are decreasing the weight of the body, is there any changes in coefficient of friction? There is no changes in coefficient of friction, because coefficient of friction is depends on the nature of the material. Thank you everyone.